Hi there, my name's Jordan Hasty. I'm currently a researcher with the Limnology Project. This is for the SURE 2020 program. So summer 2020, I'm with the Summer Undergraduate Research Experience. Today I'm going to be walking through how to create a heat map in R for a time series plot. So this is in the two reservoirs that our Limnology Project is studying. We have 10 temperature sensor arrays going from 1 meter below the surface down to 10 meters below the surface. That collects data every 2 hours, and then we have created daily averages for each of those sensors on each date. And so now we want to create a yearly heat map to display it. What we're going to do first is create a new project to base all of this in. So this is if you've already downloaded RStudio and R. You'll want to select a new directory, new project, and then we're going to call this tutorial heat. You can create it as a part of a subdirectory, and so you can browse and pick whichever one you want. I've been putting all of mine in a Limnology folder. A directory, by the way, in R is just a code word for folder, so that's all it is. We'll create it, and now it'll start up for us. Right now we are in the RStudio, which is a platform that kind of makes working with R easier. So some of the things that it has is we'll go over here and open a new R script. We have our environment, our global environment in this corner, which shows all of the objects that we've created. This area here has a lot of different things, including our help file as well as our plots. We'll be able to see some of the plots we create later on. Our console is where we are actually operating and executing our code in. You can type directly into it and it will execute. You can also use a script file, which I'm using up here. This is kind of like a notebook that you can practice your scripts in, write different code, play around with it, and then try it out as you go. It will also save all of it as you go, so it'll be more reproducible. The first thing that we're going to do is install some packages. So in R, packages are things that you can download that come with a lot of new functionalities and new formulas that you can use. So some of the ones we'll be working with today include install. You can use the function install.packages. We'll be using tidyverse. Which will come with a lot of different data manipulation tools that we'll be able to use. Install packages. We also want to install Lubridate, which will allow us to play around with date easier. We're going to install our color brewer. This is a package that comes with a lot of color functionality so that we'll be able to make our heat map look a little prettier. And then we're also going to install GG themes. This is another one that just allows you to make more appealing plots. So to execute them all, we can highlight them all and then press Control Enter, and this will execute them all in our console. Okay, and so I've gone ahead and written a little more code. Another package we'll be using today is readxl, which just has some formulas that allow us to open Excel files easier. Now that we've installed them, that is the first step, and it downloads it to your device. However, you still need to tell R that you kind of want to open this package that you've downloaded and start using it, because they're pretty big, and so R needs a little bit of a heads up. So to do this, we type library function and then tidyverse lubridate, whatever the package is called, and then you can execute that as well. Something that you'll notice whenever you start typing things like this, so if I were to type library, this is a list of arguments separated by commas. So library is a function, and then it comes with a variety of arguments inside of it. So for example, there is package, which we've used, and so that's just specifying what package we want to load up. Alrighty, now that we've done this, we want to go ahead and import our data. The easiest way to do that is to create an object that will be our data frame. So right now I'll use df, just shorthand for data frame, and then I'll use an operator. So df will be our new object. This is our assignment operator. It's a less than symbol and then a dash. That tells R to connect whatever data we're pulling up with a certain label. Now we'll use the read underscore Excel function, And so here the first thing it says is that our first argument needs to be the path. So where in your file management system can we locate this Excel file at? A good way to help find that is find out what working directory you're working from. So get working directory. And so we can see that this tutorial heat is the file that we created a little bit ago, the directory we created. And now that you see this, you can Control C and paste this all up in here. Now you also want to add your Excel file to it. So for example, what I've gone ahead and done is added this Excel file to my desktop. I'll open my File Explorer and then navigate to where we're working today, which is Tutorial Heat. And then I can add it in here. Now what I also find is helpful is if you just double tap on it as if you were going to rename it. Oops. You can just Control C. Oopsies. If you open up R again, we can just add another / and then paste the file name followed by .xlsx. If we Control Enter and display that, now we have a data frame. You can also shorthand this by just entering if your file is in your working directory, so we put it in this tutorial heat file or folder, you can just display the name of the file itself. And then if we were to Control Enter, the same thing would happen. We still have df. So now let's inspect our data a little bit. The first thing we can do is we can use a formula view. Whoops. So this shows us what our data looks like in a spreadsheet form. So this is very similar to Excel. You've probably seen this before. We see a date column, so it starts in January, and then we have 10 other columns here that's our depths. So we have 1 through 10 meters. Like I said, every meter we collect a data point every day, and so we have 10 observations per day. The only problem with this is, while this is very interpretable to a human, R as a programming language prefers its data in a different format called tidy. There's lots of literature out there about tidy data sets, so I encourage you to look it up. It's very, very common. Basically what it is each column is supposed to be a variable, and then each row is supposed to be a single observation. So for example, our variables would be date. We would also have depth, which are these meters here. So a depth of 1 meter, depth of 2 meters. These are all values of a variable depth as well as a variable temperature. This will make creating a plot much, much easier. Before we change our spreadsheet to look a little more in the tidy format that we want, let's take a few more moments to explore our data set a little more. Two formulas that you can use are head df, which will display the first 6 rows. So we can see it just again as a little snapshot. We have our dates and then each of our meters. Another one is structure, or str. Oops. This will show us a little more detail about the data itself. So we can see here that this df is stored as a data frame. It's a TBL data frame. We can also see that our date isn't quite a date format. It's a POSIX CT, which is a form of date, but not necessarily the one we're going to want to use today. We can also see that each one of these variables, so 1 meter, 2 meter, 3 meter, are character, CHR, a character type of data. The reason for this is that some, or at least one in every one of these columns, one value is no data. So this is a time where either the sensor was malfunctioning or the battery went dead in it and we didn't get a data point for that day. And so because of that, R coerced all of the values for this column to be characters instead of numericals. That's not great for us, but we'll be able to fix it up pretty well. We can actually fix this in our attempts to restructure the data. So we're going to declare a new object. We're going to call this dt for daily temperature. We'll assign it that. We can use the pivot _ longer function to change our data. If we want to get a little more help about any sort of function, we can put a question mark and then our formula, so pivot _ longer. And this will take us to a help file in R. You can see here. So pivot longer lengthens data, increasing the number of rows and decreasing the number of columns. Here are a couple of the arguments like we said, and you can also see more details about each one of these arguments later down below. So if we want to do this, our first argument is data. So we'll type data. This equals isn't necessarily an equals, it's sort of like an assigner, but we'll use our df object. Our next argument is cols for columns. What we're going to do here is look back on our df and look at which columns we want to change. So we want to change column 2, which is 1 meter, all the way to 10 meters, which is column 13. So the way we can do that is put a sequence 2:13. Our next argument is going to be names2. So this is what we want to change the first variable's name as, and we want to call this depth. The next argument we're going to use will be names_transform. So what data type do we want depth to be? Oops. And we want to make this into a numeric data type. To do this, we'll follow the same formula as they see here. So we'll use the list function. List, open it up, and then we'll type the variable, which we've just declared here as depth, and we are wanting it as dot numeric. Perfect. Our next one, we'll do values transform. So this will be what our other one is, and we're going to make this list temp as numeric. And finally, we'll declare what our values to label will be. So values, oops, and we're going to call this one temp. All right, now we need to close this off with one final parenthesis because we opened a parenthesis here. And if we declare this, we see 12 warnings were declared. If we look a little bit closer at this, so if we were to open up this, the warnings were just showing that our no data were turned into NA, which means not available or null data entry in R. But otherwise, it looks great. So now we have 3 variables, date, depth, and temperature. And then for each variable, we have 1 observation. So January 1st at 1 meter, this is the temperature. So this is a little bit more whenever we were talking about wide to long. Humans can sometimes interpret wide data a little bit easier, so we can see, you know, on January 1st all the way across what it was, whereas some programming languages prefer to see things long, where they want to see each observation. Now that we've created this new data frame, let's go ahead and take some more time to explore it again. So if we use those same formulas we used last time, so head, we'll use structure, and then this time we'll also use attach. What attach will do is it will attach the variable names, so date, depth, and temperature as objects similar to here, although they won't be visible, and this will allow us to use them in formulas later easier. So if we run them, we see another screenshot or another snapshot of our data, and we can also see that our depth now is a numerical and our temperature as well is a numerical variable, which is great. Our next step is going to be to start to visualize what our plot is going to look like. So if we go to plots here, we won't see anything, but if we want to think about it, what we want to have is depth on our y-axis and then date on our x-axis, with all of these variables in the middle being different colors representing temperature. If we think about this depth on our y-axis a little bit more though, because of how our data operates, we're thinking about the surface of the water up here, we want to go down the water column. So 1 meter down, 2 meters down, 3 meters down, 4 meters down, and so on. This is a little bit different than most y-axes would go, where you would have 1 at the bottom all the way up to 10. Because of that, we're going to have to do a little bit of playing around with our depth category. So what we can do here is create new variable names for each of our variables to make them in the right format, including changing our depth. So first we'll try date as dot date. Because we've attached the objects here, we can just say date and it recognizes it as coming from our data table. Otherwise, if you haven't done that, you can always use dt and then the accessor operator, which is a $sign. And so this is saying from the dt data frame, dt over here, we want to grab the date column. You also can change temp. Just make that temp as it is. And then finally, whoops, our depth. The first thing that we're going to do with depth is we're going to make it a factor. Factors are a little bit of a weird data type. They're kind of like categories, but they can be ordered. So they're different buckets, but they're ordered buckets. Declare these, and then we can also inspect the levels of our depth, because since factors can be ordered, they have different levels to them. So we can show that here. And we can see that 1 is the first variable, or 1 is the first level all the way to 10. And so this will, on a y-axis, would be, as we talked about before, 1 at the bottom, 10 to the top. So what we're going to want to do is reverse the levels of depth. We can do this by using the depth object again, and then changing a little bit using the factor formula. If we look at factor, the first is going to be, this is basically what our x variable, which is our depth. We want to say levels is equal to the reverse of the levels of depth. And so what this is saying is we want to reverse the levels of depth, and we've already seen that the levels of depth are 1 to 10. If we use this, and then we can go ahead and display depth again, we see now that our levels are 10, 9, 8, all the way down to 1. So now that we have all of our variables over here in the right format, we can go ahead and start looking at how to make a plot. So you can always, if you want to comment on your script, use the hashtag. This is a really great way to document what you're doing and kind of explain what you're doing, showing your steps, or if you get a script from someone else, often it will be commented to document what steps and what reasonings whoever created the script had for creating it the way they did. So what we're going to want to do is declare p or any other variable name as our new plot. We're going to use the ggplot function. So if we look at ggplot, we'll pull up a little bit more about it. ggplot initializes a ggplot object, so it's going to be the graphic that will display our data. The first argument is that data. So the data we're using will be dt. The second one, mapping. You can learn a little bit more about how ggplots and plotting works on a whole bunch of places online. Basically, AES, or the aesthetics, the mappings, is how the data gets. Let's look it up. So it's how the variables in the data are mapped to the visual properties of the geomes or geometries, which the geometries can be things like line plots, bar plots, scatter plots, or what we're going to be using is a tile plot. Either way, we can see on AES that the arguments we're going to need are at least an x variable and a y variable, and then we have lots and lots of other options here. So right now, we're going to declare our x variable to be date, our y variable to be depth, and then we're also going to use a fill, which will be temp. And so this will fill all of our little tiny tiles or boxes with a temperature value. If we go ahead and Control Enter on this, whoops, there we go. If we just enter P and run that, this will show our new plot that we generated. So we can see a plot with our x and y axis, but we haven't given it a geometry. We haven't given it the how to map it on there. So to do that, we can use our P, our plot object that we've already initialized, and then rewrite over it. So we'll use P now is going to become P plus a geom. This plus sign is really important because in ggplot, it's how you put new layers onto a graph. You can do a layer like this using an already created object, P, or you could always do it on one line, similar to this. So you could put a plus sign, enter, and then create more layers and just keep going, keep going. However, we are going to split it up a little bit just so that we can see this step by step. The next thing we're going to want to do is add a geometry. So we can use P plus geom underscore tile. Now we're starting to see something that looks a little more like a heat map. Our next steps though, let's play around with the coloring a little bit more so that we see something that gives us a little more sense. Maybe something with like red to blue, showing from hot to cold. To do something like that, what we can use is redeclare our plot object that we've been working on, P, and we're going to add a new layer called scale underscore fill underscore distiller. As we can see here, a short little description. The big thing is that it's going to provide color schemes from Color Brewer, which we downloaded earlier. So the first thing that I want to do here is start to think about this scale over here and what values we want it to go from. So right now it's going somewhere from 90 to somewhere below 50, which are the highest and the lowest observations we have in here. But we want to make sure that we have a consistent scale over all of the heat maps that we make for both of our reservoirs, and that's just to ensure that we can compare them side by side and know that they're all on the same scale. For the most part, they have always shown a range in between 40 degrees and 90 degrees, and so that's what we have been using, but you can always check that on whatever data you're using by using max, and we'll use temp, which is NA. So if we look a little bit closer at the max, we see the second argument is NA.rm, which stands for NA.remove. It removes any NAs. Right now it's false, so it's not removing NAs, but we want it to be true. So we'll use max temp NA.rm equals true. Now if we do it again, it's 90 degrees, so 0.08, so it's basically 90. It's very, very close. We can do the same thing for min temp NA.rm equals true. And now we see it's 40, so it's within the range that we're going to declare. To declare that range, we'll put limits on our scale, and so we'll say limits equal to C, which stands for concatenate. It means to combine a couple variables or to combine a vector. We'll use 40, 90, and then our other argument is going to be a palette argument to declare what sort of palette we want. So ours, we can use yellow, red, blue. Now if we declare P again, let's see how everything turned out. Oops, so we see that yellow, red, blue didn't quite work out. So if we think a little bit more, we should probably do red, yellow, blue. Let's give that another shot. I have a little cheat sheet over here. We'll use red, yellow, blue. My bad. Red, yellow, blue. Now if we see it, this looks much more like a heat map we're used to seeing, with red as the hot on top and blue as the cool on bottom with our scale as we talked about. Our next couple steps are to start thinking about our x-axis and our date down here. So let's change this scale a little bit. I think it would be better to not include 2019 and only include the months so that you see it as a little bit cleaner. The way we're going to do that is if we redeclare p, we're going to use a function called scale underscore x underscore date. Whoops. We want to use the helps function there, so we don't need the parentheses, but we do need the question mark. So this will change our scale for date and time. A few of the arguments we're going to be using are date breaks and our date labels. So if we scroll down to our arguments, we see date breaks. We can give that in a string between two quotation marks. We're going to be using 1 month. And then on date labels, we have to give this with a code. If we want to see the codes, we can click on this and then scroll down a little bit. Here are our codes down here. We want to use, we'll try %B, which will be full month. If we want to apply this, we can use date breaks to be 1 month. And then we can also apply date labels to be that %B. We try this out, we get no errors. If we display it, we see here a little bit better. It looks like we got full months, which we don't necessarily want because it looks a little crowded. Maybe if we try %B lowercase. This changed a little bit, and so this is much cleaner and much easier to read. We might as well keep going, playing around with this, with both of our labels and our axes. What we can do now is start thinking about renaming them. What we'll do is we'll actually use a function called labs for labels. If we look at the help function here, some of the things we can add with it are a title, a subtitle, caption, so on. We can also add an X label and a Y label. So if we scroll down, we can also always see a couple examples at the bottom of the help file. These are sometimes helpful if you're thinking about how does it actually get used. What we might use labs for, we can add a title. We're going to call ours, we'll call it daily average temperature in water column of, let's scroll back down and see, we got it from Lake Varner in 2019. So we'll say Lake Varner and in parentheses, or in quotation marks, parentheses, yeah. We also want X to equal date and Y to equal depth in meters. We'll put that in parentheses as well. Now if we run this, display P again, we can see things change a little bit. So we have date change and we have our depth changed, but our title isn't quite what we want. It's kind of long. What we can do here is actually add a break. So if we broke it up right after water column, what we can do is put a \n, and if we try this again, we can see that we added an enter, we added a new line. Two more little tweaks. We want to rename our label for our legend over here. So we can use fill, and we'll rename that as temperature with Fahrenheit. Excuse me if I misspelled that. I'll fix it later. And then we also can add just the word sensor depth right there. So let's try it one more time. Show P. And that's looking a little bit better. So now our last thing that we can do is start to play around with some of the finer details of our graph to get it publication ready. I'll be honest, I'm going to cheat here, so I have my cheat sheet here. And some of the things we can do, some visual tweaks to make it more appealing. We can use a theme, so we downloaded a theme earlier. Theme Tuft will just make a couple changes to the fonts automatically for us. With our plot, we can also do a couple more theme changes. So for example, we have a plot title, and then you have to use the element text argument. And so we wanted to justify that, which just means to center it around the center. We changed the size a little bit of the text. We also changed the angle of our x-axis to put it a little bit more crooked, so that's maybe a little bit easier to read. And then we changed our border. And so let's just see what all of this stuff looks like. If we display this, this looks much, much better. So we have a couple font changes. We have an angle to our title, or to our axis labels. We have a border around the edge, which looks a little prettier. So there's just a couple little details that help make this ready to send off. The final steps we can do here is, if you're writing this code from scratch, you would save it. And then you can just save it as, say, Heatmap script. And then you can also export it. So the way you can export it, you can write code for it. It's also just as easy to use export drop down here, save it as an image. That seems to save the ratio a little bit better. You could call this Heatmap LV 2019. It automatically saved it to our working directory, so if we pulled that back up and we were in tutorial heat, we can now see that there's an image file in here, a PNG, and if we were to open that up, one moment, it will display in the ratios that we saved it in here. So here we can see everything works out really well. PDFs is also another option to export, but sometimes that will change your ratios a little bit. So just play around with whatever works best for you.